Today we will be discussing Einstein coefficients and their relation. So let's begin. Firstly, let us understand the three types of emission and absorption that we will be encountering in this relationship. So, firstly, we have stimulated absorption. Now, this looks like this. It's going from the lower level to the upper level, and the rate of absorption here would be, I will get back to this later in like explaining this, so please just note this down for now. So next we have spontaneous emission. It looks something like this from the upper level to the lower level, like we can, which is obvious because this is emission. And the rate for spontaneous emission looks something like this. And lastly, we have stimulated emission. This looks like this. Now the rate of stimulated emission looks something like this. Note this down if you have to, or if you noted it while I was writing, that's great. Now this right here is the Einstein coefficient for stimulated absorption. And this here is the Einstein coefficient for spontaneous emission, which is Einstein coefficient for spontaneous emission. And this right here is the Einstein coefficient for stimulated emission. Yes, so now we can move on and define some of the terms that I mentioned here other than the coefficients. So n x This is the number of atoms or molecules or particle, whatever we have in a level, and now S mu is the energy density per unit frequency of incoming photon. Now the units for this, we can derive the units for this. Okay, I will just go ahead and do that. This isn't really important, you will never be asked about this. Now under, hold on, let me just, so you guys can see this. This is what we have so far. Now under thermal equilibrium, number of upward transitions is equals to number of downward transitions. This implies that N1 S mu B12 is equals to N2 A21 plus N2, this so now we'll have to solve this. So keeping this, taking this common, we have this we can term as our first equation. Now let's divide each term of RHS by into P21, which will give us this. And now this will be our second equation. Now we know from Boltzmann's relation into is equals to E S by E minus E1 over KT. So 3. Hold on, let me just check something here. Yeah, sorry. We have this here. Yeah, this right here. Now moving on from here, we have this. But from Planck's energy distribution formula, we know that S mu is equals to 8 pi h over delta, so what do you call this, or whatever, or lambda. Now this was our equation 4 and this is our equation 5. You guys can read this. Okay, now lastly, the comparing 4 and 5, B12 over B21 is equals to 1 implies B12 is equals to B21, and A21 over B21 is equals 8 by h over, and therefore B21 is equals to 3 8 by h. A21 is to B12. And yeah, that's it. That's our relation. That is what we have here. This here is the relation between Einstein coefficients. Thanks a lot for everyone who watched the video. And if you have any doubts, you can ask them in the comment section. Yeah, and I will just go through this once more, one last time. So if anyone missed anything, or if anyone wants to note it down, they can. Yes, that's limited. Thanks a lot.